So here we have a function of two variable f, which is given by x raised to the power of y. We need to show that here we have the third derivative of function f with respect to y, followed by the partial derivative with respect to x taken 2 times, and this must be equals to the third partial derivative of f with respect to z, y, and x. We'll come to that a little while later, but let's start with whatever we are provided with. So here we are given the function f equals to x raised to the power of y. So our task will be to obtain the partial derivative of f with respect to x and partial derivative of f with respect to y. Now to do that, we cannot use the power rule here, because here we have a variable raised to the power of another variable. We can only apply the power rule whenever we have a function raised to the power of some number or some constant value. So in our case, we have a function raised to the power of function. The only way to find its derivative is by first applying the logarithm on both sides. So we'll take the logarithm. So we'll have logarithm of f as equal. So here ln represents the natural log. So we'll take the natural log on both sides. We have natural log of x raised to the power of y. Now immediately it follows that whenever we have log of a raised to the power of b, this becomes equivalent to b times log of a. That means we will get natural log of f equals to y times natural log of x. So let's label this as number 1. Now what we'll do, we'll take equation number 1 and apply partial derivative of x on both sides. We are partial with respect to x of log of x, which will be equals to partial with respect to x of y log x. So derivative of the logarithmic function gives us 1 over f times partial of f with respect to x. So here we have applied the chain rule, which is equals to y is a constant because we are taking the derivative with respect to x. So we can pull it out of the derivative and we are left with the partial derivative of log of x, which is simply 1 over x. So that means we get partial of f with respect to x will be equals to f times y divided by x, where f will be x raised to the power of y. We'll replace it at later. So let's label this as number 2. Now using the same equation, what we'll do, we'll take the partial derivative with respect to y on both sides. So we have partial of log of f with respect to y equals to partial with respect to y of y times log of x. The partial derivative of log of x will be 1 over f times partial of f with respect to y. So this will be equals to log of x is a constant, so we can take it out of the derivative. So we'll have log of x multiplied to partial of y with respect to y, which is simply 1. So that means partial of f with respect to y. So that gives us the value f times natural log of x. So let's label this as number 3. So we will be using 2 and 3. Now coming to the left hand side of the expression, so this actually means, so we have to take the partial of f first with respect to y. So after this is done, we will take its partial derivative with respect to x, and whatever result we obtain, we will again take its partial derivative with respect to x. So this is actually the same as the third partial derivative of our function f with respect to partial x squared and partial y. Right. So what do we need here? So since we're starting from the left hand side, so first we will need partial of f with respect to y. So we can use 3. So we will use number 3 and we'll take its partial derivative with respect to x. So let's begin. So we have from equation number 3, partial of f with respect to y equals to f times natural log of x. So what we'll do, we'll now take the partial with respect to x on both sides. So we'll take partial with respect to x of f times log of x. So this will become, we'll have to use the product rule here. So we have partial of f with respect to x multiplied to natural log of x plus f times partial with respect to x of natural log of x. So this means we have partial of f with respect to x times natural log of x plus f times, so partial of log of x will be 1 over x. So we have f over x. And we have also obtained the value of partial of f with respect to x. So let's note it down as well. We have partial of f with respect to x. So that's given by fy over x. So this was obtained in equation number 2. So let's use this value as well. So we will have fy divided by x times natural log of x plus f divided by x. So this is the value of partial of f with respect to y, and then we take its partial with respect to x. So now we have this particular value. So this came out to be fy over x times log of x plus f over x. Now what we'll do, again we'll take the partial derivative on both sides with respect to x. So we'll take partial derivative with respect to x of partial with respect to x of partial of f with respect to y. So that means we will take partial with respect to x of fy over x times natural log of x plus partial with respect to x of f over x. Fine. So here y is a constant because we are taking the partial derivative with respect to x. We have y multiplied to partial with respect to x of f over x times natural log of x added to partial with respect to x of f over x. Now we will find out the partial derivative of each of the terms. So let's begin. So this will be equals to y multiplied to, let's use the quotient rule. We have f log x divided by x. In the denominator we have x squared. In the numerator we have x multiplied to partial with respect to x of f times log x minus f times log of x multiplied to partial of x with respect to x. Fine. Plus, again we'll use the quotient rule. So we have x squared. In the numerator we have x times partial of f with respect to x minus f times partial of x with respect to x. So this is going to give us y multiplied to, here we'll apply the product rule. So we have x times, we have partial of f with respect to x times log of x plus f times partial of log of x, which will be simply 1 over x, minus f times log of x, partial of x with respect to it. So that's going to be 1 whole divided by x squared plus x times partial of f with respect to x minus f times 1 partial of x with respect to x is 1 divided by x squared. Means this gives us, we can take x squared as the common denominator. So we have x squared. So in the numerator we have y times x times log x multiplied to partial of f with respect to x plus fy divided by x minus fy times log x. This will be added to, we have x times partial of f with respect to x minus f. So this is the value of the third derivative, partial derivative of f with respect to y, followed by partial derivative with respect to x applied 2 times. So wherever we have partial of f with respect to x, so we are going to replace it with y times f divided by x. So let's do that. So we have y x log x multiplied to partial of f with respect to x will be replaced with y times f divided by x plus fy over x minus fy times log x plus x times fy divided by x minus f, whole thing divided by x squared. So this gives us, so we have this x and x cancelling out. So we have y times log of x. So we have y squared times log of x times f plus f times y divided by x minus fy times log x. So here x and x goes away. This gives us fy minus f divided by x squared. So here I have missed out one x. So this x, when it multiplies, gets multiplied to f over x. So I missed out the x here. That is, there's an x here. So there's x in the then x in the denominator also cancels out, so this leaves us with fy. So this will be simply fy. Now that means our final expression will be, so we have y squared log x times f plus, so this fy added to this fy becomes 2 times fy minus fy times log x whole divided by x squared. So this is going to be our expression for the third partial derivative of f with respect to y, then with respect to x taken 2 times. So we are going to leave it aside and we will compare it with the expression that we obtain when we find out the left hand side as well. So let's do that. So there's a typo in the question. So actually this is partial with respect to x. So for the expression on the right hand side, all we have to do is first find out the derivative, partial derivative of f with respect to x, followed by taking its partial derivative with respect to y, and then finally obtaining the partial derivative with respect to x. So we already have obtained the partial derivative of f with respect to x as given in equation number 2. So that means we'll now obtain, so let me write it down, number 2. This gives us partial of f with respect to x. So that's equals to f times y divided by x. Now we'll take partial with respect to y on both sides. So we're partial of f with respect to x. This will be equals to partial with respect to y of fy divided by x. Now x is a constant, we can pull it out of the derivative. So we have 1 over x multiplied to partial with respect to y of f times y. So f being a function of x and y means f also has a y dependence. So we cannot treat it as a constant. Right. So that means this will be equals to 1 over x times. So here we'll have to use the product rule. So this will be partial of f with respect to y multiplied to y plus 1 over x multiplied to f times partial of y with respect to y. So that gives us y over x times partial of f with respect to y plus f over x, here partial of y with respect to y, that's simply 1. So this is the second partial derivative of f with respect to x followed by y. Now we also have the value for partial derivative of f with respect to y. We have partial with respect to y, so we obtain this value to be equals to f times log x. So we will use this value. So that means our expression will become y times f divided by x times natural log of x plus f over x. Right. Now what we will do, we'll take the partial derivative with respect to x on both sides. So that gives us second partial derivative of f with respect to x and with respect to y. So this will be equals to, so since we're taking with a partial derivative with respect to x, we'll treat y as a constant. So where y multiplied to partial derivative with respect to x of f log of x divided by x plus partial with respect to x of f over x. Fine. So let's find this value. So this will be equals to y times. So here we will apply the quotient rule. So we will start with the denominator. We have x squared. Now we will have x multiplied to partial with respect to x of f log x minus f times log of x multiplied to partial of x with respect to x separately. So this will be equals to x squared. In the numerator we have x times partial of f with respect to x minus f times partial of x with respect to x, which will be equals to y times, so this is multiplied to x times, so here we'll have to use the product rule. So that will become partial of f with respect to x times log of x plus x times f times 1 over x minus f times log of x whole divided by x squared added to x times partial of f with respect to x minus f divided by x squared. Now this y is only multiplied to the first term, so this will be equals to, so now we can multiply y with each of the terms within the parentheses. So we have xy times log x times partial of f with respect to x plus, so here x and x goes away, so we have f times y minus f times y times log of x. So we can also add the numerator because we have a common denominator of x squared. So we have x times partial of f with respect to x minus f whole divided by x squared. The third derivative of our function f with respect to x followed by y and then again followed by x. So this will be equals to xy times natural log of x. Now we'll substitute partial derivative of f with respect to x with fy divided by x. Now let's multiply that with fy divided by x plus fy minus fy times log x plus x multiplied to, so we again have partial of f with respect to x, so this will be fy divided by x minus f whole divided by x squared, right? So there are a couple of terms that will get cancelled out. So here we have x and x cancelling out, x and x goes away, and we can combine some of the like terms to get y times log of x times f times y. So this will become y squared plus, so this fy and this fy will become 2 times fy minus fy times log of x minus f whole divided by x squared. So this is what we have obtained for the expression on the left hand side, third derivative of f with respect to x, with respect to y, and with respect to x. Comparing this with the expression that we obtained for the partial derivative given on the left hand side, we have, so we can see that all the terms matches, and here we can say that, hence we can say that the third derivative of our function f with respect to y followed by with respect to x taken x 2 times, so this will be exactly equals to third derivative of our function f when we take it with respect to x then y and again with respect to x, hence proved.